Greetings, Terraformers. You asked the question, and today I'm going to cover my pattern around Azure KeyVault as a key value registry. I'm Olaf Gradin, and this is my lovely co-host, Jason Ford. Before I get into the how, let's talk a little bit about the why. As your infrastructure as code gets a little bit more complex, you may find yourself in a position where you are stringing together multiple operations and will need to pass information from one to another, if that makes sense. This is traditionally what we take for granted within the context of like a CI/CD pipeline, but you may prefer a third-party registry that can work across multiple pipelines or represent a source of authority for your pipelines. And we were talking just backstage a minute ago, having a source of record or a source of authority for values or attributes that you use within the organization can be invaluable. And it's something that we, I think, oftentimes forget about until after the fact. So getting this set up in advance will save you a lot of headache there. The strength in a key value store or a registry is also that you could be granting access to other people to your keys, and so then everybody else can take advantage of those platform environment attributes more easily. You don't, so as you set up these source of authorities, you don't necessarily have a way for others to gain access to them. But if you conceive of that up front, then you can set up the security, the infrastructure to support your app developers to be able to gain access to these values as well. Now, you might naturally go to HashiCorp's console for this service, but if you're operating in something like Azure, you may prefer to use an Azure native service. You have two options here, one being app configurations and the other being Azure KeyVault. Azure KeyVault is perhaps not one that you would readily assume is a great place for your key value stores, but I'm going to show you a pattern around the way that I use it for that exact purpose. And let's also cover quickly why I would use KeyVault versus app configurations, which is designed a little bit closer to this purpose. One being, and this is kind of the question that came up in our Discord channel, is around size constraints. You may remember this one, Jason. Somebody had asked how they can get around the size constraints that exist within app configurations. The values are limited to 10 kilobytes. And I mean, that's actually pretty large for just key value pairs. But if you're storing complex objects, then I can understand where that can easily be exceeded. Azure KeyVault allows you to go a little bit further than that. So it's 25 kilobytes within Azure KeyVault. Other than that, you would probably have to chunk your value across multiple items, multiple values to go beyond 25 KB. So that makes Azure KeyVault a good use if you are storing larger objects, but obviously not more than 25 KB. And then the other is security. So obviously Azure KeyVault is designed for encryption. That's its primary motivation. Everything that you store in it, in fact, will be encrypted. But rather than thinking that as a downside, I think of it as an upside. I don't have to worry about whether I encrypted a particular key value pair. Everything's encrypted. So using Azure KeyVault, I just dump everything into it. I know that everything's encrypted. I can use I can use a strong form of encryption. I was actually just thinking about whether I can use customer managed keys, and honestly, I don't remember if that was the case. I kind of
on the secrets.
Yeah, on secrets within Azure KeyVault. I know this is something that's changed over time, so I don't know the current.
I'm not sure. I've never seen like an option to set that. Right now, I can create a certificate and then use it to encrypt other things, but not the secrets themselves.
Yeah,
but it's possible.
The other thing would be, well, so this is still security. App config, when it uses encryption, it's actually using KeyVault on the back end to do the encryption. So if you're going to use app configuration, you're limited to 10 KB, but then if you want to encrypt it, it's going to spin up a KeyVault or require a KeyVault regardless. So at that point, I feel like, well, I'm just going to use KeyVault, encrypt everything. It's a larger key value store, and the cost is not very great. The pricing on Azure KeyVault, non-HSM backed, is actually pretty good, pretty competitive.
I think it
we
starts off free, right? And then it's based off the number of transactions you use it for.
exactly, yeah, I was going to say it's consumption based. So if it's just a key value store, you're probably not using it a lot, and so yeah, it wouldn't be horrendous by any means. So with that, I'm going to get into just kind of showing how I set this up. And so we've talked a little bit about the why. So now I'm going to show you the how. Okay, so looking at the code, I now have a couple blocks of code up here, and this is basically just a piece of code that generates network information. So network, subnets, maybe some security elements, logging elements. And so I have here a keepers block, which creates my KeyVault in this case. And then I have a network security block, which is creating the VNets I just talked about. So when we look at this, I'm going to produce a bunch of information that might be usable by other people. And if I look at the subnet code that's being generated here, I've got all this VNet and subnet information. And this stuff obviously becomes pertinent for others to consume as they need to integrate their own infrastructure with the environment. So I would have to take like the VNets and the subnets, and I would have to provide those to my consumers so that they would be able to use that within their own code. So if I look at the output that I have already, I can see just that type of data. So I have subnets and load balancers. I have CIDRs for the VNets and subnets. I have names and resource group names, all very important information that I would need to pass on to other people for them to consume. So this information is good, and I would, if I were communicating with somebody and I were running this code by hand, I might just copy these values and paste them out to people. But obviously it's not very sustainable. I want this stuff to be maintained in a source of record. And then when I go to run other steps, I want to consume these pieces of information so that those steps are getting the latest and greatest. If Jason goes and makes changes to the environment, then I need to capture those changes without hitting him up to find out if there were any changes to the environment. So what I'm going to do then is convert. Right now, these are all listed as outputs. So I'm going to convert from showing these outputs to now writing out to the vault. And in this case, the code for the vault is pretty simple. So the first thing I need to do is I'm going to data source the vault that was created in previous steps. So the keeper created the vault. And so this name and resource group name are obviously important for me to reference in this code so that I can then refer to the same vault. So I do that. And then thereafter, everything is just creating vault resources. And so I'll just uncomment these lines. And you can just see kind of by way of example here, it's a lot like an output, actually. I can almost directly convert output code to KeyVault secret code. So you can see here the resource is Azure M KeyVault secret, and then I name it whatever I want within Terraform. And one little peculiarity is that in Azure, the secret names have some naming restrictions, and this is I'll put a link in the description, but there are a lot of naming qualifiers for resources within Azure that would be worthwhile to understand the ones that you use most commonly, and be aware that you can find out what the others are too. So for instance, storage accounts are limited to a much shorter, they're alphanumeric and they're much shorter string. KeyVault secret names likewise are limited, so they have to use dashes. You aren't allowed to use underscores within their names. And I think they are alphanumeric plus dashes, maybe dots. I don't remember all of the things that they provide. And then I specify the value that I want to use for that secret. And so in this case, I'm referencing a resource that's actually created within this code. And I then specify the data source that we put at the very top of the code where I referenced the specific key vault. And that's all there is to it. So then if I apply these things, and what we'll see here is that these key vault values are going to show up inside of the secrets, that the secret blade within that configuration. So as those are being written out to the KeyVault, then they're going to show up just within the secrets blade of the KeyVault configuration. And so we can see here that all of the items that I referenced or that I generated within the IAC now show up within the KeyVault secrets. And I can click on any one of these, and digging a little bit, I can show the secret value, right? They're not all secret, but I have chosen just to store everything as an encrypted value within KeyVault in this case. And shown or not, you can always copy the value to the clipboard, so you can grab values even though you can't actually see them if you choose. So this is the storage part. So now I need to actually make use of this and put it into some code where I'm going to reference those values as well. Okay, so let's cut over to the next block of code. This is going to be just a block I've called registries. And within registries, the first thing that it needs to do, obviously, is reference the KeyVault and the resource group name where the KeyVault lives, so that I can then use that code. Now, a next piece of important code is another data source on something called Azure KeyVault secrets. And what this does is it actually pulls all the secrets from the KeyVault and into a single data source. And that can be really useful if, like in this case, I'm going to grab all the KeyVault, all the keys, and do something with them. But you could also grab individual secrets. And so the next bit of code actually does that. The data source Azure KeyVault secret, singular, right? I've got a plural one and a singular one. The singular one is looking for, it'll result in a single item that you can reference within data source. So in this case, I take my secrets, which is a list of those things, and I'm going to create a set based on that. So I do a for each on the secret, and I convert that to a set, and then I basically just loop through so that I have one data source for every secret that's within the vault. And this is just a handy way for me to grab all the things. It's probably more likely that you're just grabbing the specific things that you need. But for demonstration purposes, I thought this was helpful because it allows us to see all the values this way. So they were encrypted before. And if I take a look at what we've got within registries, I want to just output those values. So I'm going to output the registry names here. I did a little bit of parsing on this particular one. So I basically took all of the secrets. There are a whole bunch of secrets created from the secrets that exist. So what I did is I just looped through that map, and that was the secret data source map. I looped through that to pull key values off of it. So we can see that I've created something called local.bulk, and that is just a key value map from the other map. Let me go ahead and get an apply on that. Okay, so this apply code doesn't actually do very much. All that it really does, there's no main, if you may have noticed, within the file menu. So all it really does is produce an output based on the inputs that we're pulling in via that data source. And unfortunately, it's marked as sensitive, and that's because it is coming from KeyVault. And so Terraform is aware that that is a sensitive source. And even though I put in the code sensitive equals true, I don't really have the option of saying sensitive equals false. I can't override that behavior. So in order for me to output it, period, I have to remark that it is sensitive. And then if I want to see that output, then I can just like do a JSON out on that. And so now we can see all of the values that were in KeyVault. So these were encrypted in KeyVault, but by tying into this with a data source, I can fetch those values unencrypted because I have access to the KeyVault. If I didn't have access, then obviously none of this would work. So even though I'm using it as an encrypted key value store, I have ready access to it as just transparent text strings or as clear text strings. So this becomes pretty useful if I need to reference like any one of these keys that I'm highlighting here. Any one of these keys that are here, I can reference individually and get the value outside of it. So if I'm looking for a load balancer, I can reference Azure front-end private IP, and it will give me the value 10.1.2.196. So that can be pretty handy for us to use. I mentioned before that I did a little bit of for work on the data source. So it's a map that has multiple values in it. And obviously looking at the values, we see each of the individual values that I can access. I want to show how I want to identify one of these values, because for instance, if you need to access one of these specific values out of something like an app service, one of the reasons you might use app configuration, you could call an app configuration value, and that works perfectly fine. If you needed to instead call a KeyVault value, then I can access any of these keys as long as I have a data source to the secret itself. So I'm going to create an output now. And this one will be the VNet name. All right, and the value for this is going to be the data source. So it's going to be data.azure.am KeyVault secret.this, and then I need to use the associative member of the key that I'm looking for. So in this case, I'm looking for Azure VNet name, which we can see right down here. It's part of the collection, and I want to get the value on that particular item. And this, again, is going to be, since it's coming from the KeyVault, is going to be remarked as sensitive, even though it may or may not be. So I always have to remember to include sensitive equals true if I'm dealing with outputs. Now, obviously, as it pertains within KeyVault, it is sensitive, and I don't have to remark it that way. So I'll add this. We'll go ahead and apply that change. Okay, and we're only making changes to outputs, so I'll include that. And just like before, I can't see it natively, or I can't see it in the clear because it is remarked as sensitive. Terraform protects the console from that material, but I will be able to output it programmatically as I've done in the past. So I'm just going to tell it to display JSON. Incidentally, I can also do a raw display, so I can say for things that are just strings. It doesn't always work if they're objects. So this is called VNet name. Yeah. So since it is just a value, then I can pull out strictly that text value, and so this can be used in an app service, in anything, and it doesn't even have to be related to Azure. I can dial into the KeyVault and reference these values for anything that I want. And this makes it important for being a source of record, because it remains for anyone to consume at any time, and you can control access to these values as well. We've shown how to reference a single item. We've shown how to pull a complete list of items. We now want to just give a little bit of a test, because one of the things that we said KeyVault was good at was storing larger blocks. So app configurations are limited to 10 kilobytes. KeyVaults are limited to 25 kilobytes. We just want to kind of test that out and make sure, because it wasn't real clear on the documentation what that referred to, if it was in fact the value, or if it was the encrypted value, or if it was a chunked portion of the value. I couldn't tell. So I need to store something in KeyVault that is large enough. So I'm just going to generate a text file that will be 10 kilobytes. So this is the limit that exists for app configurations. And then within my code, I'm going to store in KeyVault. So now I have a new resource that I'm going to add to KeyVault. And this one is going to use the value of that file that I just created. So we're just going to import the contents of that file and store it raw as something within KeyVault. Okay, so we're going to apply that. It's going to write it to the KeyVault, and we're just going to confirm that it's out there. So this is a 10 kilobyte file that I created, and we're storing it. So we know that this should certainly work within the limits. It is the limit of the app configuration. Okay, so it created that, and let's actually just jump over to the secret store. We're going to refresh that. We now see that there is a complex bulk object. That's what we created. And I'm going to Grab that value. Oh, it's a mess. Okay. It is just random text. All right, so here's the value of that secret. Yeah, so here's the value of the secret. It is 10 kilobytes long, just random text. So that works. We're able to store that. Now I'm going to change that, and I want to increase the limit. So we know that 10 kilobyte works, and we presumably know that 25 kilobyte works. 25 kilobytes is a little bit larger than that, but this is close enough. Apply that. Okay, and if this is successful, then that means that it was able to support the 25 roughly kilobyte file, and we can see that result in the secret store. I won't go to it yet, because if this is successful, then I want to move beyond that. And it was able to add that resource without any problem. Now let's bring it a little bit higher. What actually happens if we go above the limit? All right, and we'll apply that. So we're currently in the validation step where it reads everything that's out there, compares it to state. And so validation was successful. It's going to let us apply this to Azure KeyVault. And there we go. Okay, so we got an error on that, and we can see very plainly within this error message that we've exceeded the length, and 25,600 is exactly 25 kilobytes. So that's just it, right? And an inner error secret is too large. So I like that. That gives me the feedback that I need to know and confirm that 25 kilobytes is our limit for the secret, not the encrypted value of the secret. And just, I guess, for yeah. So if I look at, let me go back to the 25 kilobyte file. Yeah. So if I look at that file, it is under the 25 kilobyte limit. And so we can just kind of confirm that we are the number that we said it was. And when it was at 28, it was just a little bit, it was under the 28 kilobyte limit, but it was well over the 25 kilobyte limit. So just kind of as proof that that file was that size. So yeah, I think that indicates exactly the value that we want out of KeyVault. That successfully shows that Azure KeyVault is a good alternative to AppConfig. It's a great option for a key value store. It has a larger size limit. We confirmed that. I can I can search for everything that exists within the KeyVault. I can reference multiple KeyVaults, and I can also reference distinct values within the KeyVault. And one other thing that I'll mention, I'm not showing the screen right now, but KeyVault has the unique side effect that every value you put in it is stored as a version of itself. So every time you make a change to the KeyVault, it basically tracks a record of what those changes were. So you have different versions of the secret as it goes back over time. So in theory, you could then pop over and pull one of those older values or see the change record. So you get a little bit more value out of KeyVault as a key value store than maybe some other options that are out there. Jason, I believe you used AppConfig before. I don't know that you've used the service, but you've certainly used the localized AppConfig within services, right?
Yeah, that's right. In the app services, you have an app settings, and in there it stores the environment variables for that specific application. And how I've used it is I use it to reference secrets within KeyVault. So it goes to KeyVault and grabs the secret out of KeyVault, so that it's not hard coded in my Terraform, just like what we're trying to resolve here. And then for connection strings, I can set the SQL connection string. I can create it using the values in Terraform. So because you already have the password generally, and you have the username if you have to use it that way, and you can create the connection string in KeyVault, then reference it in your app settings.
Honestly, I don't know how app config settings can be referenced outside of Azure directly. I'm fairly certain that they can. I just don't know what that PowerShell or AZCLI code actually looks like. But if I were to imagine interfacing with KeyVault, it's relatively simple for me to query a KeyVault secret and show the value directly from it outside of Terraform, outside of Azure, because I'm doing that within the AZ-CLI or within the PowerShell Azure RM module. So there's a lot of value in using these native services to be a source of record elsewhere, because it gives me a clear way that I can set and get those values while still maintaining some restriction on those things as well, because obviously the ACLs still apply. If you don't have access to it, then you can't get to it.
I've also used like Terraform to set my secrets for Azure DevOps, and then use the pipeline to pull in those values too. That's a little out of scope from this conversation, but using Terraform, you can manage KeyVault like you were showing. It's pretty easy as long as you have the right ACLs, which is half the battle.
Yeah, and I think this is a really good point too, because in ADO, Azure DevOps, it obviously, at the very beginning of this conversation, I mentioned working within a CI/CD pipeline. We kind of take for granted the fact that you can pass values along your pipeline from one task to another. That's just what pipelines do. The problem, though, is that if I store all my values there, it's not a great source of record if I want to use something outside of the pipeline. So in this case, it may be better for me to use a separate registry, no matter what it is, and then seed those values into my pipeline environment so that it can make use of those things that are actually centrally maintained elsewhere.
And also with secrets, you don't generally want to store them hard-coded.
Surely not.
Even in KeyVault, or not in KeyVault, but in DevOps. If you store in KeyVault, like you said, it's encrypted. It's one spot. So if I change it in KeyVault, everything else will be updated down the pipeline.
Right. Yep. And you can control access to it at the network level as well as at the user level. And it's very granular in terms of what access you can assign to it. Now, what I will say, KeyVault being cheap, right? We said KeyVault itself is free. It's the consumption that you pay for, and even that is relatively cheap. I think the pattern or the encouragement that Microsoft would give you is to create as many KeyVaults as you want. So regarding that, what's interesting about it is that I can't create like multiple secret stores within one KeyVault. So I can't have like a secret store for platform high security, low visibility things, and then app developer low security, high visibility things in the same KeyVault and set up permissions differently on those. So the permission granularity within KeyVault is such that you apply it to the secret engine, not to the secrets themselves. So I said earlier, they encourage a different pattern. The pattern is that you create a KeyVault per, we'll say rights barrier, right? Per permission barrier. So if you need different permissions on the secret store, you need a new KeyVault. All right, so that concludes what we wanted to talk about today. If you liked this video, like and subscribe to our content to catch updates, which we post about once a week. Also, join us on Discord. There's a link in the description where you can engage with an entire community of people learning Terraform just like you. You'll find Jason and me there, and we'd love to meet you. Thank you.
Thank you.